Welcome to iLectureOnline, and in this series we're going to talk about the concept of a vector. Now a vector, as I described here, is a mathematical representation of a physical quantity that has both magnitude and direction. So what do we mean by that? Well, let me first give you some examples in physics of the kind of things you're going to encounter. You're going to encounter forces, so we can represent the force with an arrow. And in this case, and let me explain a little bit more here, in this case when we draw an arrow to represent a vector, the length of the vector, the length of the arrow, represents the magnitude of that vector, the magnitude of that quantity. For example, when we talk about a force, if I draw a long vector, I talk about a large force. If I draw a small vector in the same direction, I talk about a small force. And so the only difference here is that if it's long, it's large. If it's short, then it's small. But in either case, the direction is the same. Now, if I draw a vector, for example, in this direction, notice that the length of this vector, or the length of this arrow, and the length of this arrow is about the same, so the magnitude would be the same. The direction just simply would be different. So definitely we use arrows to represent vectors, and the length of the arrow simply represents how large that quantity is. The direction of the arrow represents the direction in which that quantity is acting. In case of a force, it would be acting to the right, or it would be acting in this direction. So here I have a little drawing of somebody pushing a box, and so that person is exerting a force on that box. The direction of the force is from left to right, and the length of that arrow represents the amount of that force, how big that force is. Here I drew a charge, let's say a positively charged object, and I drew lines in all directions. That represents the electric field around this charged object. And the length of these vectors, or the length of these lines, or arrows I should say, represent the amplitude, the magnitude of the electric field. And of course you can see all the different directions simply represents that the electric field goes out in all different directions. Here I have, let's say, a soccer ball, and the soccer ball gets kicked in this direction, so it will have momentum in this direction. Momentum is simply a product of the mass, which is a scalar quantity, and we'll get into that in just a moment, times the velocity, and the velocity is a vector component. So we have mass times a vector, velocity, and the result of that is momentum. P stands for momentum, and that's also a vector. The longer I draw the arrow, the greater the momentum, meaning the greater the mass or the greater the velocity. And of course the direction is clear, it's up in that direction. Here I drew an example of a car. It's traveling from left to right. It has a velocity, it's like a speed and a direction combined. The length represents how fast the car is moving. The direction shows you the direction of that movement. So I did mention another word. I mentioned the word scalar. So let's compare what a vector is versus a scalar. So we have a vector vs scalar to accentuate the difference between the two. A vector quantity is simply something that has both a magnitude and a direction. A scalar is something that only has magnitude. For example, if I talk about the mass of something, that has no direction. It's just how much stuff is in it, and so that's a scalar quantity. But a velocity can be fast or slow, so it has magnitude. It can also have direction. That makes it a vector. So a vector is a quantity that both must be expressed in terms of how large it is, magnitude, and in what direction it is, either what direction an object is traveling or the direction that the force is being exerted and so forth. So that's the difference between a vector quantity, which has both magnitude and direction, and a scalar quantity, which only has magnitude. All right, that's a little introduction to vectors. In the next so many videos, I'm going to show you what we can do with the vectors. We're going to be adding, subtracting, multiplying vectors, and so forth. And that'll give you some idea of how to work with that. Vectors is a very fundamental quantity, very fundamental thing in physics, and you have to really understand this.